All right, so we have Properties of Dilations. This is 10.1. So if you watched the Introduction to Dilations stuff that Mr. Ferrari put out, some of this, the beginning is going to be very much review, but that is fine. Okay, so first to start with the definition, a dilation can change the size of a figure without changing the shape. So shape is going to stay the same, size is going to be different. So what we're going to be doing is we're going to be using ratios and the ratios of the corresponding sides of the two shapes that we look at to determine whether or not it was a dilation or if the shapes just look a little bit alike. Okay, so the first thing we're going to do is we're going to need to make sure we are aware of what our corresponding sides are. So corresponding sides just means it's the same side of the shape in both shapes. So in this case, the height, these are corresponding sides. So I'm changing the colors. Okay, so those are the corresponding sides. The bases correspond. And then we have our, hypotenuse. Hypotenuses? Hypotenusi? Who knows? Hypotenuses. That sounds funny. All right, so now that I've changed the color of these triangles, you can see which sides correspond to which. So the next step is we need to identify lengths. Okay, so we need to know which sides correspond and we need to know how long each of those sides is. Now, in order to do this, you only need like 2 sets of sides. We do not need to use the third side in this triangle, and if you had a rectangle, you wouldn't need to use the third and fourth side. So in this case, we're not going to be using the hypotenuse in order to determine whether these two shapes are a dilation. So it's called similar. So if the two shapes are similar, or if one shape is a dilation of the other. So if one shape is either an enlargement or a reduction. Okay, so we're going to start with this. And the way I'm going to be looking at it is that the shape that's on the left will be the pre-image and the shape that is on the right will be the image. All right, so this is where we started and we did something and ended up over here. That's the idea. Okay. Oh. Stop. There we go. All right, so we are going to determine the side lengths. So this one, 1, 2. This one, 1, 2, 3, 4. 1, 2. All right. So once we've done that, we have enough information that we should be able to determine whether or not this is a dilation, if a dilation has occurred. So to figure out if a transformation is a dilation, compare the ratios of the lengths of the corresponding side. So here's what we're going to do. I'm going to change these and put them in the right colors because, you know, it's just going to make it easier to see what we're doing next. All right, so we said this was 2 and this is 4. We said this is 1 and this is 2. All right, so what we're going to do is we're going to make 2 fractions now. Now, don't be freaked out. As long as you follow the same pattern, you'll be okay. All right, so we're going to make 1 fraction with our 1 set of corresponding sides and 1 fraction with the other set of corresponding sides. So this is what I mean. I'm going to take where I'm starting. Oops, let's just purple because that's what we're looking at. I'm going to take where I'm starting. So my small shape, that was my pre-image. I'm going to put it over. No, for ease of math, let's do it this way. We're going to put the image over the pre-image. And we're going to put the image over the pre-image. That's how it's supposed to go. Okay? So where you ended up over where you started. So do you see how I have both of my purple sides in one fraction here, and I have both of my green sides in 1 fraction here? That's what you're going to be doing. Okay? So then from here, easy peasy, we just simplify these fractions. Okay? So the next step we need to do is we need to simplify. And we're going to do that by dividing the numerator by the denominator. Okay, if, I didn't write it down there, so that's okay. If the numbers are the same after you create the ratios and simplify them, that means that this is a dilation. Okay, you're always going to want to put your preimage in the denominator and your image in the numerator. So this is the image, okay, or second shape. Okay, and this is the first shape. And we're going to think of it as first to second as left to right, or in whatever information you're given. If you're said this was the first shape and this was the second shape, then you'll know. Okay, second shape on top, first shape on bottom. All right, let's compare some more. All right, so we are going to, again, change the color of our sides so that we can keep track of our corresponding sides. And then just for fun, just to make sure it always is the same, our hypotenuse is yellow. Okay, so we are going to determine the lengths of the sides. So for our smaller triangle or our preimage, our first shape, our side length is 3. And for our second shape, our image, our side length is 1, 2, 3, 4, 5, 6. And our base in our preimage or our first shape is 2, and a base in our image or our second shape is 4. Alrighty, so now just like before, we're going to put the corresponding sides into 2 separate fractions, and we're going to put our second shape number on top or in the numerator. So I'm going to put 6 on top and 3 on the bottom to represent our purple sides, 4 on top and 2 on the bottom to represent our bases or our green sides. And then now we're just going to simplify to check if, that was weird, to check if in fact it is a dilation. So if it's a dilation, the number will be the same. Okay. Now it's not always going to be 2. Those just happen to be the examples that I picked. These are the same. It's a dilation. Alrighty. So now let's do another one. So are they always going to be a dilation? No. That's why you're learning how to check. Okay. So again, same thing. We need to identify which sides are which. For some of you, you're like, yeah, I got it. But it never hurts to have a lot of practice of the same thing kind of over and over again to help us really get it. All right. So we have identified the corresponding sides. Now we are going to make our ratios where we have our second shape. Oh, we need to figure out the lengths. I rushed. 3 and 5. 1, 2, 3. 1, 2, 3, 4, 5 for our purple sides, and 1 and 2 for our green sides. All right, so now we're going to make our ratios. So second shape, numerator, first shape, denominator. Second shape, numerator, first shape, denominator. I'll just leave it as green. Now we divide. Ugh. Without even finishing, I know that these aren't going to be the same. Because, so do you see that? Did you see how I looked at this and was like, that's ugly. That's not fun dividing. And then I went down here and I completed this one. That's a skill you can use. That's a trick, kind of, or like not a trick or a shortcut. It's just something that the more you do math, the more you're going to be able to identify, well, I don't really want to do that one. I also have to do this one. So if I do this one first, I get a nice little number here that's 2. I know that 5 divided by 3 isn't 2 because 6 divided by 3 is 2. But let's just perform it. So 5 divided by 3. 3 goes into 5 once. 3 goes into 20 6 times, and then we are just going to have a repetition here. So this is 1.6 repeating. These are not the same. So this is not. All right. So the next piece of this, if the ratios are equal, then the transformation was a dilation. So not equal, not a dilation, equal, dilation, equal, dilation. Okay. All right. So now we're here. When you determine that the corresponding sides are equal, the number is called the scale factor. Okay. So the number that we found here, this is a scale factor. That's the number you multiplied the sides by in our pre-image to get our image. 3 times 2 is 6. 2 times 2 is 4. 2 times 2 is 4. 1 times 2 is 2. Okay, so that's a scale factor. So using the same thing as we did before, I guess I can do the base first. We're going to, why not? Oh no. Okay, well I guess I'm stuck with green. So we're going to figure out the side length. So I'm just going to leave that one blue and this one will stay green. For some reason my thing doesn't want to change. So this is going to be 2 and this is 4. This long side here is 3 and this long side here is 6. So we're going to put them in 2 fractions with the corresponding sides. So let me try it again. Nope. Okay. So I have my second shape over my first shape, second shape over my first shape. So we've done this one already, but that's okay. 6 divided by 3 equals 2. 4 divided by 2 equals 2. Okay, so the scale factor for this one is 2.